Hello, my flock of children. Today, we're learning about multi-step conversions.
So like we're two-stepping?
Yeah, right. So,
Okay.
we're still doing chemistry, right? Not dance class.
Right.
So, multi-step, we're going to learn how to go from grams to moles to particles, and from particles to moles to grams. So, lots of steps. Be careful. Okay. So, first, let's take a trip to Mole City. Do you know what Mole City is?
It's a city of moles.
Okay, so let's put moles in the center of Mole City. Okay, so now on this side, I'm going to put grams. And on this side, I'm going to put particles, if I can fit it. Everything has to go through Mole City. Okay? So, if you remember from our other practices, anytime you're going 2 moles, we're dividing.
Okay, towards moles we're dividing.
So if I'm going this way or I'm going this way, I'm going to be dividing. So if I'm going from grams to moles, what am I dividing by?
Grams to moles you divide by molar mass.
Okay, so divide by molar mass. Now if I'm going from particles to moles, I'm dividing by
Avogadro's number.
Avogadro's number. Okay, so you're always dividing because you want to end with moles, so moles goes in the numerator, the top of your train tracks. Okay, so now if I'm going away from moles, well, if I'm not going to be dividing, what else would I be doing?
Multiplying.
Multiplying. So anytime you're going away from moles, you're multiplying by molar mass to get grams. That makes sense because if I know 1 mole has 10 grams, then if I had lots of moles, it's times 10.
Right.
Okay, so if I'm going to particles, I'm multiplying by Avogadro's number. So if you remember this map, you'll never get into trouble.
All right.
Okay, so now let's do some practice. All right, so what do you got there?
I got some aluminum foil.
Well, how many grams do you think that is, human scale?
Let's place it on the scale. I'm going to guess that it's approximately 35.2 grams of aluminum.
See, that could be a source of error.
Mr. Veve does not make errors.
35.2 grams of aluminum. So now we're talking about 1 element. Okay, now the first thing I want to do is go to moles and then to particles. So let's do it in 2 separate steps this time.
So this whole thing is going to go from grams to particles eventually.
Yes.
How many particles are in here? Okay.
Okay.
This is really exciting. I'm sorry.
Okay, so we have 35.2 grams per our human scale. And we know that 1 mole goes on the top because we're dividing. We're going 2 moles. So 26.982 grams of aluminum in every 1 mole. Where did I get that number from?
You got that from the periodic table of elements.
Yep, that's the molar mass of aluminum.
Great.
And it's kind of messy because I messed it up.
That's okay.
Okay, so how many moles is that? Human calculator?
Well, multiply the top divided by the bottom. That's going to be about 1.30.
So we still have 3 sig figs. Oops.
1.30 moles.
Moles. We've canceled out our grams.
Okay.
So I've got moles. Okay, so if I have 1.30 moles, I'm not done yet because I want particles. So moles, set up my train tracks again. I'm going to put 1 mole down here because I want my moles to cancel.
And we're converting to...
And I'm multiplying.
We're converting to particles now.
Right, so I put Avogadro's number on the top. 6.022 times 10 to the 23rd particles. So what would I get?
You would get approximately 7.83 times 10 to the 23rd atoms of aluminum.
In atoms because we're talking about a single element.
Single element, the particle is atoms.
Okay, easy enough. 2 steps.
2
Remember,
steps.
everything goes through moles.
Everything goes through moles, 2 steps. Still looks like 2-stepping to me. Right. Let's see what we're doing next. So now we're going to go the other way, right?
Yeah.
Well, I got some salt right here, if you guys can see. This is 100% kosher NaCl, an ionic compound, by the way. And in here, there is approximately 2.21 formula units.
So why are we using formula units?
Well, 2.21 times 10 to the 23rd formula units, I should say.
Oh, okay.
We're using formula units actually because all ionic compounds, the particles that you call them, the representative particle, is formula units.
Okay. So formula units
Okay.
of NaCl, the ionic compound.
The kosher ionic compound.
Okay. So now we're going to go from formula units to moles to grams, and I'm going to set it up in one big step.
Okay, one long train track.
Yes.
That sounds a bit ambitious.
So let's do 2.21, and remember the E button, E23, okay, so that I can fit it all. Okay, that's my formula units.
So we have to go first to moles.
Okay, so that means first I'm going to divide.
Divide by Avogadro. So 1 mole goes there, and Avogadro's number goes on the bottom.
And this is particles, but because I'm talking about formula units, these guys cancel. Okay, and now to go from moles to grams, I multiply by molar mass.
Right.
So what is the molar mass of NaCl?
About 58.443. Just did it in my head. Grams per mole.
Grams per 1 mole. So now we're ending with grams.
Oh, the moles cancel
the moles
too.
cancel, your particles canceled, and we end with grams. So you can set it up in one long step if you're comfortable doing that. If not, you can continue to do it in 2 steps. So we end up with...
So we multiply all the numbers across, divided by the product of the bottom numbers, and we end up with 21.4 grams of that wonderfully kosher NaCl.
Is that pretty accurate to what you thought it was?
That was exactly what I thought it was, actually.
Okay.
So
now, our inspirational message from Mr. Veve.
Whether you think you can or you can't.